Today's lesson is lesson 7 from unit 7. Today's lesson is on practice with rational bases. Our goal for today: I can change an expression with a negative exponent into an equivalent expression with a positive exponent. Our second goal: I can choose an appropriate exponent rule to write to an expression to have a single exponent. Here we go. So as we work through this slide presentation, we would like you to work with your workbook. Open up to page 38. If you don't have a workbook, that's okay. You can still follow along. So open to page 38 in your illustrative math workbook. All right, let's remember our 5 rules. Kind of give us some background, a little refresher. So our first rule is when we are multiplying bases with same base, different exponents, we're going to add our exponents. So n plus m. So our answer would be our base of x with our exponent of n plus m. To show how it works, if we have the base of 4 to the second power times the base of 4 to the third power, we have 2 factors that are 4. Because it's 4 squared, so 4 to the second power, and we have 4 to the third power. So there should be 3 factors of 4, 1, 2, 3, for a total of 1, 2, 3, 4, 5. 5 factors of 4. So our answer is going to be 4 to the 5th power. So if we said 7 to the 5th power times 7 to the 6th power equals 7 to the 11th power, what we're doing is we're going to add our exponents. 5 plus 6 is 11. So now we want you to try these on your own, right? Using a single exponent, similar to what we just did here. All right, why don't you try these? Pause it. We'll come back and get our answers. All right, let's go over these. So the very first thing you want to look at are your bases. Are they the same? And they are indeed. So we are just going to add our exponents. So we have negative 3 plus 8 is 5. Notice we had different signs, so we have to subtract. 8 minus 3 is 5. There's more positives. 8's bigger than 3, so our answer is going to be overall positive. So our answer is going to be 3 to the 5th power. Our next one, 2 to the negative 4th times 2 to the negative 3rd. We're going to add our exponents. We have like signs, so we're just going to keep the sign. Add and keep the sign. So negative 4 plus negative 3 is negative 7. So our answer is going to be 2 to the negative 7th power. Our third example, 5/6 to the 4th power times 5/6 to the 5th power. We have the same base of 5/6. So we're going to keep those in parentheses, but we're going to add our exponents. 4 plus 5, they're both positive, so we're just going to add them straight across. It's 9, so we're going to say 5/6 to the 9th power. If you're getting hung up on those, please contact Ms. Kumber or myself. Next rule, we're dividing. So when we divide, our exponents are going to be subtracted from one another. So we would subtract n minus m. So we have our base, take our exponents and subtract it from one another. So this is how it would work. If we had 3 to the 5th power over 3 to the 2nd power, and we wrote it as expanded form, so that's telling us we're going to have 3 times itself 5 times. So 3 times 3 times 3 times 3 times 3 over 3 to the 2nd power. So that tells us it's going to be multiplied 3 times itself twice. 3 times 3. So then if we were going to match up, try to eliminate some. So I have 2 on the bottom, our denominator, and we have 5 on the top. So these two could match with 2 on the top. That's what this is showing. They would essentially cancel and become 1. Then all we have left are these last 3. So 3 times 3 times 3. So I said this would be equal 1. And then we have 3 times 3 times 3, which is 3 to the 3rd power. 1 times 3 to the 3rd power is 3 to the 3rd power. So if we said 3 to the 5th power over 3 to the 28th power, we're going to subtract those. 5 minus 28 would equal negative 23. So our answer would be 3 to the negative 23rd power. So remember when subtracting with negative numbers to add the opposite or use leave, change, opposite. So let's try these on your own using a single exponent. Try these three. Pause the video. All right, let's go through these. So when we are dividing, like bases, we're going to subtract our exponents. So we're going to go negative 5 minus 4, negative 5 minus 4. And if we were following our format of leave, change, opposite, or sometimes it's keep, change, flip, either way would be the same way. So we're going to keep or leave, negative 5 the same. We're going to change the sign from minus to plus, and we're going to make our number behind it its opposite. So right now it's a positive 4, and now it becomes a negative 4. So now we're just going to add across. So negative 5 plus negative 4 is negative 9. So our answer is going to keep our base of 2 to the negative 9th power. We have the same base of 6. We're going to subtract our exponents. So this time we're going to leave. So we have change. We're going to change our minus signs to a plus and make this negative to its opposite. So now it becomes positive. So 5 plus 8 is 13. So its answer is going to be 6 to the 13th power. Last example, we have the same base. So we're going to subtract our exponents. Negative 12 minus 20. Negative 12 minus 20. So we're going to keep or leave. We're going to change our sign. So from minus to plus, and we're going to make our number opposite, or flip it. So our opposite of positive 20 would be negative 20, so then we just add across. Negative 12 plus negative 20 is negative 32. So our answer would be 10 to the negative 32nd power. Next rule, power to power. Means we're going to multiply our exponents, n times m, n times m. So how does this work? To prove it, so if we had 8 to the 2nd power, all raised to the 3rd power, we're going to multiply our exponents. So what this is showing us, so inside our parentheses we have 8 to the 2nd power, and we need 3 groups of that. So 8 times 8 is the first group, 8 times 8 again is the second group, and 8 times 8 the second group. So this 8 times 8, it's 8 to the 2nd power right here. That represents that. And this tells us how many groupings we need. We need 3 groups of 2 factors of 8. So we have a total of 1, 2, 3, 4, 5, 6. So it's going to be 8 to the 6th power. We have 6 factors of 8. All right, so if we know 7 to the 2nd power, all raised to the 3rd power, 2, we're going to multiply our exponents. 2 times 3 is 6, so 7 to the 6th power. So now let's try these on your own, right, using a single exponent. So pause the video, try solving these 3. All right, let's go over these. So we're going from power to power, so we're going to multiply our exponents. 3 times negative 3. 3 times negative 3 is negative 9. We have unlike signs, so our answer is going to be negative. So our answer is going to be 4 to the negative 9th. This one, we're going to multiply our exponents. So negative 8 times negative 4, we have like signs, so our answer is going to be positive. 8 times 4 is 32, so our answer is going to be 2 to the 32nd power. And our last one, we're going to multiply our exponents. Negative 3 times 5. We have unlike signs or different signs, so our answer is going to be negative. 3 times 5 is 15. So the answer is negative 15. So our final answer is 6 to the negative 15th power. Remember our rule, any number to the 0 power equals 1. To show how that works, if we had 7 to the 5th power, and we multiply that times 1, it'll be 7 to the 5th power. Well, if we took that 7 to the 5th power and multiply it times 7 to the 0 power, in our rules that we know, we have to add our exponents. 5 plus 0 is 5. So that's telling us if we knew that 7 to the 5th power times 1 is 7 to the 5th power, we should know that anything to the 0 power is going to be 1. Another way to show this is using the division. So that means we're going to subtract our exponents. If we had 7 to the 6th power over 7 to the 0 power, so we're going to subtract our exponents. 6 minus 0 is 6. So that's telling us it works that any number to the 0 power has to be 1. So if we know 5 to the 0 power equals 1, now we're going to try these on your own, right, using a single exponent. So pause the video, try solving these three. All right, so here we go. This one's a division problem, so that means we're going to subtract our exponents. Keep our base, but subtract our exponents. 5 minus 5 would be 0, so it's going to be 10 to the 0 power, and we can bring that down further. Anything to the 0 power is 1. This one's power to power, so we're going to multiply. So we keep our base, so 4 times 0 is 0, so our answer is going to be 3 to the 0 power. 4 times 0 is 0, which equals 1. Anything to the 0 power is 1. And when we're doing our last one, we're going to be adding our exponents, being that we're multiplying here. So add our exponents. 8 plus negative 8 is 0. So our answer is going to be 2 to the 0 power, which we can reduce further to be 1. Anything to the 0 power is 1. Our next rule that we've been working on is when we have a base with a negative exponent and how to make that into an answer, a solution that makes our exponent positive. In order to do that, we're going to take the reciprocal. So think of this as a whole number over 1. And we're going to take the reciprocal. That means we're going to flip it. So the 1 will become on top where our numerator is, and our base with our exponent will go to the bottom, or our denominator. And when it goes down to the bottom, our denominator, our exponent will become positive. So this shows you how this would work. So if we had 9 to the negative 3rd power, if I want, being that this was a negative exponent, it's going to tell us that we are going to be multiplying by 1/9, 3 times. 1/9 times 1/9 times 1/9. So we have 1, 2, 3, so it'd be 9 to the 3rd power. 1 over 9 to the 3rd power. So if 2 to the negative 7th is 1 over 2 to the 7th, now try these on your own, right, using a single positive exponent. So most times when we're asking for solutions or positive or exponents, we want it to be positive. You're going to see that more and more as we get through the unit. So let's practice these three. Make these into a single positive exponent. Pause the video. All right, so this one, right, using a single exponent, what we're going to do is just take the reciprocal of this to make it a positive exponent. So it's going to be 1 over 3 to the 23rd power. Notice all I'm going to do, if this was over 1, the 1's not going to be on top. The 3 to the negative 23rd will go to the bottom, but when we go bring it down to the bottom, take the reciprocal, it now becomes positive. So we're just going to set it as a fraction. The next one, 1 over 8 to the 11th. Once again, when we bring it down to the denominator, it becomes positive. And our last one, 1 over 4 to the 9th. So how would we actually evaluate 2/3 to the 3rd power? So what that means, we're going to be, if we did this in expanded form, 2/3 times 2/3 times 2/3, because they're telling us we need to multiply our base, which in this case is a fraction of 2/3, 3 times. So if we did that, 2 times 2 times 2, that's our numerator. So that's 2 to the 3rd power, and 3 times 3 times 3. We're doing that 3 times, it's 3 to the 3rd power. So if you notice, we are, when we're dealing with fractions like this, with an exponent, we need to do the power to the numerator and the denominator. So 2 to the 3rd power, 3 to the 3rd power. And then we're going to evaluate this. What is 2 times 2 times 2, or 2 to the 3rd power, is 8. And 3 times 3 times 3 is 27. So let's take a look at these. Are these the same or different? Think about that. So let's look what's different about it. This one has parentheses. This one doesn't. Oh, take a guess. Same or different? Will it come up with the same answers or different answers? Hope you said different. So to prove it, we're going to have -4 times itself, -4, 2 times because it's to the 2nd power. Let's look at this one. So we have a negative sign, and we're going, -4 times -4 will be +16. Now let's take a look at this one. We have -4, we have a negative, but we're going 4 times 4 again, because that's what it's telling us. So -4 times 4 is 16, but then we still have this negative, so our answer is going to be -16. So they're opposites of one another. So why is that? So the exponent is squaring the value in the parentheses in this case. So the negatives are true to both, or however many groupings there will be. In this case, there's 2 groupings because it's to the 2nd power. This one, the exponent is squaring only the 4. So that's what's really, you have to be very careful when you're dealing with solving, is looking for if there's parentheses or not. If there's no parentheses, we're only squaring, in this case, is the 4. Not worrying about the negative sign. The negative sign will follow along at the end. All right, so let's get through this. True or false? 1/3 to the 2nd power times 1/3 to the 4th power will equal 1/3 to the 6th power. True or false? I hope you said true, because they have the same base. So we have 1/3 and 1/3. Yep, that works. Now we just have to add our exponents. 2 plus 4 is 6. Yes, that works. Take a look at this one. True or false? We have 3 to the 2nd power times 5 to the 3rd power equals 15 to the 5th power. Think about that. True or false? Hope you said false. They don't have the same base, so you can't add the exponents. So you notice we have 2 plus 3 is 5. So they do not have the same base, so you can't just add the exponents or multiply the bases. In this case, they did both of them wrong. All right. Next one. True or false? 5 to the 4th power plus 5 to the 5th power equals 5 to the 9th power. True or false? Hope you said false. 5 to the 4th and 5 to the 5th are not being multiplied. So we don't add the exponents. This would have to be multiplied in order to have that work. This is an addition problem, so we can't do it that way. So our learning targets, once again, what we just went over, I can change an expression with a negative exponent into an equivalent expression with a positive exponent. And lastly, I can choose an appropriate exponent rules to rewrite an expression to have a single exponent. So any questions, feel free to email Ms. Kumber or myself. And that's it for today. So head on over to Schoology and complete today's assignment.